Hello, hello. It's February 21st, 2023. It's a SIG Node Sidecar Working Group meeting. Welcome, everybody. I wanted to start with what we wanted to discuss last time, sequencing of work. I started looking at the implementation, pardon me. And I mean, if we implement all in one shot, it will be a huge PR. Not because it's a lot of functionality. In fact, it's not that much of functionality that I mean, looking at like all the places I need to change, it's not that much, but at the same time, it's touching so many pieces of code. So I wanted to break down a little bit. And in fact, we already started this work a little bit like Todd here on the call already doing one of these actions. So yeah, I wanted to discuss the breakdown and maybe like we can brainstorm on more ideas what to do. Is this font good enough? Because I copied it from some markdown thingy. I can make it bigger. Yeah, is it okay?
That's good. Yeah,
it's okay.
So I wanted to break work down into pieces. What's needed before we change API, before we add the flag. What we can do, like in terms of refactoring and like unifying of code. Then what's the minimal work we need to do with API change, like single PR that brings necessary functionality. And then what we can do after we did API change, so we can add extra pieces of functionality that is not, I mean, that is needed, but it's not like absolute minimum. I think where we can start is let's discuss what we can change with API change, like minimal things that we need to do. So minimal thing we need to do is first at startup, we need to wait for started, not for completion for those init containers for sidecars. Then we need to keep reconciling status of sidecars, so it wouldn't be like unexpected. So like every time we reconcile, like it's expected that this container is in internal, like is init container, it's not a regular container collection. And then termination, yeah, we need to, like when we decide whether, like when we look at containers being terminated and we still have a sidecar running, we need to terminate all the entire pod and like all containers anyway. So this is a third piece of thing that we need to do. And then resource calculation update is also like small piece that without that it wouldn't be, I don't think we can get this, take this PR without this resource calculation update. I'm not sure about topology and CPU upgrade. Like it's not absolutely necessary from my perspective. We may decide to put it into after collection, but we may want to tackle it in the same PR as well. And I'm saying that because Todd is making this work on unifying this logic for resource calculation among multiple pieces, and topology manager was one of these pieces. So maybe it will be no op like handling these two in the same PR. I'm not sure yet. I didn't look very deep into this code. So I think this is absolute minimum that we need to do in single PR with API change. What it means that we need to do like logic of restarting of sidecar on failure, we can do it later. I mean, it will be started in a sequence properly. It will keep living, but if it will fail, it will fail. Like we can do this part later, like after we complete like first PR. Then we can enable props on sidecars also later. Matthias already looking into logic of making sure that started field will be set on init containers properly. And it will be set before any probe, so it will be set unconditionally. So we wouldn't allow sidecars to initialize properly. But I mean, it's not super critical for this PR. We can always say that it's separate PR that will come later, and it's like it's not very complicated. It should be quite targeted and like in specific area. Then yeah, pod ready state calculations should also be can also be postponed. We want this. We want to make sure that sidecars can affect pod readiness, but we can do it later. We don't have to do it before. And I looked at this logic. It feels to me that this logic already will work just out of the box once we will enable probes, but we still need to write some tests, I think, to just make sure it's working properly. Lifecycle hooks also can be enabled later. It may happen that it will be easier to handle it along with this, but I don't think so, because to enable lifecycle hooks, the biggest change will be changing API validation. So whenever we admit a pod, we need to, like, right now we don't allow init containers with lifecycle hooks, so we need to start allowing them. So API validation will be fixed in here, but I think implementation-wise, it will just work, because start container function doesn't discriminate types of containers. It does the same logic for all of them. It just doesn't have any lifecycle hook for init containers. That's why it does nothing for them. But ultimately, the same logic, as far as I can say by analyzing code. And then score adjustment is like minor features that we can postpone to the very end as well. So this is like in terms of like API change, minimal change, and what we can do after. And in terms of what we can do before, we already discussed whether we want to fork init containers. And I think we don't want to fork them. There was lots of feedback that it would complicate adoption quite significantly. So what Todd is doing is pod resource calculation centralization. So it will be a single function that we need to update. It will be much easier in our PR to do. And then started, as Matthias looking into that, we want to have started field for init containers be populated properly. And I want to discuss this more later in this meeting. And then, yeah.
Yes, go on.
Okay. And then we probably need to just create a CI job for pre-submit and have it ready. So whenever we have end-to-end test, I have some ideas for end-to-end test as well there. Then we can just test it on any PR, and it will be already prepared for us. So I think this is something I want to concentrate. Maybe this week and beginning of next week, so we will have some time for all these changes later.
So Sergey, so to understand, like before, with, and after, these are like 3 PRs, or these are like different PRs that must merge together?
So I think this will be single PR, because I mean, we wouldn't be allowed to do API change without any implementation. So this is this is how Kubernetes operates these days. So you cannot just say, I have this plan, all these PRs are lined up, I want to do API change first. It doesn't work this way. So we will need to likely we can try, but likely we will be asked to do all together.
Yeah.
Is this single PR?
Yeah, I was going to add one thing to that. Sergey's absolutely right. Like, there's a pretty strong line right now that we don't merge API changes without their corresponding implementation. So you usually end up with a pretty big PR. However, if you need to, you can use a branch where either like somebody's personal PR branch, and you can combine commits from multiple people there and then merge them and keep the commits separate to retain attribution. So we can still collaborate and work together on what is basically some small scale branch development if we choose to.
It's a good point.
And we have to merge like these PRs on master branch, or we wait until we have the 127 branch? No.
They go on the master. Yep. And we can merge at any time. So anytime between now and freeze, which is what is it, March, mid-March, something like that. I don't want to say date unless I know. Let me find it.
And then the changes that we can do before API change, those can merge regardless.
Yeah, I hope as soon as possible. One problem right now is Murnal is on vacation, very lengthy one, and we will need to have we need to find some approver to get our changes in. It's not trivial these days.
Yeah, it's code freeze is March 15. So if you assume you're giving your reviewers at least a week for the big PR, maybe more, we've got 2 to 3 weeks of development.
Yeah. So hopefully we can get this PR end of next week. We can try. And again, like it all depends on like whether we can merge this one as well. And after changes, do you agree with this split of with change and like after change? Does it make sense? If you would be approver, would you approve this?
Yeah, I'm trying to think if there's any here that I would consider more contentious. So restart.
And then how do we line up with the one from Vinay? Because we are touching the same areas, right?
Yeah, I don't know. Like, I really hope that like we've been discussing it on New Year that we want to merge it tomorrow, and like it's still not merged. I don't want to block ourselves on that. I think our changes very similar places, but not exactly the same place. For instance, we don't touch runtime at all, like a CRI. So we only touch lifecycle, mostly sync pod and such.
Yeah, I'm trying to guess at what I think an approver might have the most objections to on the list of after API changes. I don't have a really good intuition. I'm wondering if maybe restart on failure would be the one that they would bring up, but I'm not sure. It might be best to just find a reviewer, like an approver, and ask them like, do you agree that we could put these in as post changes?
Okay, maybe I will create an issue on GitHub with the description and then
yeah, I don't know if
maybe Derek,
Tim Hawken or Jordan might be good people we could run it by and just say, hey, like, do you think this is reasonable? And if like we get somebody saying yes, then I kind of think this is reasonable for an alpha, but they'll be the ones approving.
And I think it's sorry, Todd.
I was going to ask, if you get the API change PR in, but don't finish all of the after, would you have to revert that API change?
Basically the decision the approvers are going to make is exactly that. They're going to want the API change to be enough so that you wouldn't have to revert it.
Okay.
So they're going to try and define that bundle such that if nothing else goes in, they're okay with it.
Okay.
Yeah,
which
I was
might make them a little
that,
more aggressive than us. Oh, sorry, go ahead.
Yeah, I was going to say that we should like copy paste this into an umbrella issue because someone was asking for it on Slack earlier today.
Oh, that's a good idea.
Okay.
And then we can tag like Jordan or Tim, and they can comment on it.
That's perfect.
Makes sense. Okay. Yeah, I will do that. And if you have any other ideas how to make more preparation work, it will be perfect. So what I wanted to talk about, like, yeah, work breakdown. Like this one is started versus like new started field on init containers. So today there is a function called find next init container to run. This function basically what we need to change to we need to make sure that the next container, like we will okay to start next init container when previous init, like sidecar container or in started state. And I'm mistaken, like Matthias started this PR to initialize started field on init containers, which is great, but I didn't realize that this find next init containers works on runtime status, on this kube container pod status rather than v1 pod status. When probe manager operates on v1 pod status. So the flow goes like that. There is a sync pod that calculates changes needed to implement. And one of the changes next init containers to run. And then it's all calculated on collection, like I think this collection pod status collection, which is runtime representation of pod status. And then it calculates all the changes, it start applying these changes, and then there is a function to apply this change, like to report these changes back to API server. I think it's called something like convert runtime change to API change. or runtime status to API status, and this function will call into either before this function or inside this function, we will call into probe manager and ask to update pod status, like v1 pod status, which is, I mean, that means that this function doesn't have information about started or ready of a container. And so here's the question. To make this function like find next init container to run, know about started state, we may want to refactor probe manager completely to operate on runtime status instead of v1 pod status. So it would mean that when we calculate changes needed, we will call into probe manager to update runtime status, and then we may want to even convert runtime status into API status without even calling into probe manager. So all the logic will move into sync port rather than it will stay in probe manager. So probe manager will basically just report current status of every container in terms of probes.
So you mean that it will take the runtime status and then mix this with probe results if there are some, and then update the v1 status?
No, it doesn't even need to update v1 status. We can move the logic of updating v1 status into this function, convert runtime status to pod status. So you can do it outside of probe manager. I mean, the key here is I want probe manager to know about runtime status instead of v1 pod status.
It needs both, right?
We can keep both, or we can leave just one. I don't like. I think clearer design will be to know just about one, to not have this logic about knowing one status type and another status type. I think it will be cleaner design, but
yeah, but there is
smaller.
a philosophical difference. Like the v1 status is the status regarding the probes. So v1 container status started means the probe succeeded, and the runtime status is really the runtime status is the container started, but we don't know if the application has started inside the container.
Okay, let me open this really quick.
If it makes sense.
Yeah, this runtime status. So it has container statuses. Let's go to, yeah. Each container status, it doesn't even have a, like, it have a state, and state is one of those, yeah, created, running, exited, or unknown. It has started at, which is time when we just like called into a CRI. We don't even know whether it started. We just know that we started it at this time. And then like we don't have any probe related statuses here.
No, here we don't.
Yeah. So what I suggest, maybe we can refactor probe manager and like add ready and started state here as a Boolean variables, and then pass this status into probe manager and do it before we call into find next init container. This time, this way we will know about like, started state. Otherwise, I don't know how to get pod status from v1 pod status and pass it into sync pod loop before we calculated the changes needed.
Okay, makes sense.
Is there any opinions here? Like I know, like I know I looked at this code very recently just for the change, and I also expected that like the change wouldn't be significant, but now I realize that we need to educate our sync pod about probes status. Like before, we never needed probe status for any lifecycle calculations. Okay.
Well, my opinion is it's going to make it harder to get this through the reviews because it's going to set more alarm bells off in the minds of the reviewers.
Yeah, that's why we can do it even before we introduce sidecar containers. We just say like it's a separate smallish PR that we can try to accomplish faster.
Yeah, I think maybe we can ask Clayton about this.
Okay.
Because he was a lot involved in the life cycle and the probe manager.
Okay. Matthias, do you want to drive this and create an issue, or you want me to create an issue?
You can create the issue with your very good English, and I can open a PR against this issue.
Okay, thank you. I will try to explain to the best of my abilities. Okay. Yeah,
We should have ChatGPT to write issue descriptions.
I tried. So what I tried is I formulated the issue in very vague terms and said ChatGPT create me an issue for like good first issue for Kubernetes, and it did something like completely broken, so it didn't work. Okay, so I didn't look into termination yet, like how to. I think I looked at partially when we wanted to implement terminate pod logic. Like terminate pod logic was such that when container stopped, we wanted to kill the entire pod. So I looked briefly at this logic. At that time, I didn't refresh it yet in my mind. I think it will be pretty straightforward to understand when we need to terminate. So, and I don't remember, I didn't check if we need to do any refactoring in this logic to allow easier implementation of sidecars.
I don't think so. I think it will be very similar to what Aditi did like long time ago when we had the main container. But I think we just apply this logic on init containers instead of. I don't think it's difficult.
Okay, so you don't think we need any refactoring or change in logic? Yeah. Okay. In the concerning status, it should be straightforward. If we only run through one collection, we need to run through two collections. I didn't check, but we may already doing it. Maybe already doing it. Okay. Todd, I think your PR. Oh, go ahead.
Hello. Do we need to include the termination thing in alpha stage? Because the cap said we don't need that for alpha stage.
No, we in the first stage we didn't want to order termination, so we didn't want to complicate the logic in any way. What we want to do in first stage is to make sure that when all other containers finished, we will kill the sidecars. So this is a key lifecycle behavior. We didn't want to like what we discussed further than that. Like we not only kill sidecar containers, but we also wanted to kill them with different grace period, or we want to kill them in order. So if you have like service mesh and logging, you can define what goes first and what goes last. So like logging may need a service mesh, so logging needs to be killed first and service mesh very last. So that kind of logic will be postponed to beta, but we still need to terminate the pod when all containers except sidecars are stopped.
Okay.
That make sense?
Okay. Yes.
Okay. Yeah. Todd, I think your logic on pod resource calculation is already like. Is it? I think it's LGTM at least, right? So we need to find approver.
Yeah, there's two PRs. There's one for the calculation, and I'm still waiting for a reviewer. And there's another one that adds that total resources requested field to the pod, which is sort of the summation of all the requests for the pod. Check. I think it still needs actually an LGTM for someone.
Okay.
Or no. Sorry. Yeah, it does.
Okay, I will try to find somebody. Okay. Last topic I want to discuss today is I was looking for ideas how to write a good lifecycle test. So I was looking at some tests that implemented most of the tests, looking at status of pods. So they do some logic and they check the status of a pod. Well, thank you, Todd. I will paste it in the document. Sorry about that interruption. Anyway, so yeah, lifecycle tests. When we write lifecycle tests, we typically do some actions like start the pod, like start with probe, and then look at result. Like a result may be whether status updated to started, whether status updated to running, this kind of tests. When we start looking into more complicated logic, when like, let's say I want to make sure that lifecycle like post start hook will block execution of a next container. This is quite tricky to implement. So I was thinking, yeah, and even this like very simple test, like let's say we have a end-to-end test. End-to-end test has a sidecar container and has two containers. One goes before sidecars and one goes after sidecar. So 3 unique containers, and we want to validate the logic that we implemented startup correctly. So what we need to do, like one of the test cases would be that after a unique container, we'll start only when sidecar has started completely. So here, the way to, like, I was thinking how to implement this test. And if you only look at pod status, then we either need to have a timeout inside the container that will slow container down for specific timeout and be sure to check the status of container during this timeout period, or we need to send some message down to container saying, you are, like, I already validated the status, now you can proceed and be started. So this kind of thing. So one, like another option would be to, inside the container, we write some file, and every container in the pod writes in the same file on same log somewhere, and then we read this log file and validate the order of entries in this log file. So we can have, let's say in this case, we have sidecar being active and write some things for maybe like 30 seconds, and then we validate that when after container starts and write in the log something that it started, we never have any other entries about started, and we also, I mean, we validate after a container has the entry in this log file. So either we send a signal to container, or we write a file from within the container and then validate it, or we do some very crazy timing calculation. So timeouts and make sure that we check status between this timeout. I didn't find many good examples of, like I found many examples of first approach when we just rely on timeouts. That's basically what we do for all the probe tests. We have a timeout and we make sure that within this timeout, we don't have restarts. And we really hope that like all the starting and everything, like all initialization happens properly. I don't really like this approach, but it's what we have. So I was wondering if anybody have a suggestion how to write good end-to-end tests with either signaling into container or writing some file from within the pod, like all containers in the pod, and then consuming this file in the test. If you have any ideas how to do that the best way, it would be great if we can start writing all the tests this way.
Either writing to the same file or writing to different files in the same mounted directory, so they could have individual checks. Yeah, I run lots of the same issues with the timeouts, just end up being flaky and then having to add artificial delays, and just it seems like a lot of the flakes are from timeout related things.
I mean, with a file approach, you'll have a buffer issue when.
If you write to different files, so your sidecar writes to one file, and your primary containers write to a different file, and then at the end you can sort of check across them, or even have the container check to ensure that, hey, the sidecar file should exist, or else I fail or whatever.
Yeah, I mean, with a single file, I don't think there will be a lot of buffer issues. Like, let's say one container wrote something and then next container have troubles writing, like wrote something and then first container buffer flushed. So I think we can avoid this by flushing preemptively. With different files, yeah, I agree, that will be tricky. it may be tricky. Yeah. And even with file approach, I don't even. I mean, I don't know what the best file would be to write, and where this file should be. Like we can try to write on a host somewhere, like mount some host folder, but then we will require all the pods to write on the privilege modes, which is not ideal either. We can try to write std out and then consume logs, but it's also may not be super reliable.
Is there some kind of network lock tool available that you could use?
No, I didn't find any, so that's why I'm asking.
Like, I don't really know what Boscos is. Isn't it like a resource locking thing?
No, I don't think so.
Okay.
Boscos is a, I think it's a pool of machines, no?
I'll put
Maybe
in
they're
the-
talking about different things. Okay. Yeah, if you find any examples of good lifecycle tests, I will also ask around if anybody has ideas how to write them perfectly. I think we can implement this test without complications like advanced techniques, but if we can find a good technique to use, it will be perfect. I think that would be what we need.
The only other thing I think of is like update the same config map, and then use like resource versions. So you know you're updating the latest copy. At least you avoid a file in the file system that way. But then everything needs permissions at the API server, and it just gets
Yeah, it makes it complicated. Yeah, I was thinking also about what is it like opening some socket back to test.
Yeah.
Oh,
Putting up a daemon of some kind and talking to it.
Yeah. And also I was thinking about like some agnostic host already have some command. So do you know agn host containers that we use in many tests? It's a image that we create, and this image has different functions. So it may expose HTTP server, for instance, or it may expose gRPC server. It may expose like different things for different purposes, and you can code whatever you want into this. So I was thinking maybe we can have some command servers there, and like just when you start a container, we can send some HTTP signals there. But then it will be a little bit trickier when you check, for instance, like some lifecycle hooks, because during lifecycle hooks there is no port to connect to. So it would be better if container connects back to us rather than we connect to container. And yeah, that creates another complication. Yeah, maybe Clayton would know if there a good way to test it.
Yeah, AGN host was the only thing I knew of that was useful. We use that for webhooks, but I don't know anything about the startup rooms.
Okay. Yeah, that's all things I wanted to discuss. I really like the idea of creating a separate branch with permissions for this work. I may need to create this. And yeah, I think we have action items. Is there anything else we want to discuss today?
This is great.
Hey guys, I was just gonna quickly chime in. My name is Ahmad, a DevOps infrastructure engineer, big fan of the CNCF, user of most products, contributor of not many, nearly as many as I would like to. And that's like 1+, I would say. Anyway, I'm trying to make my rounds to get a feel for the different SIG groups. Really just kind of being open. There's some, obviously, I think all of us are more interested in than others. But you never really get a good feel of how things are like running and like what are some of the challenges that are facing each one until you like jump in. So it's awesome that they're open to the public, obviously, just general sort of like open source and SIG groups across Kubernetes and maybe some other projects as well. But yeah, I just wanted to introduce myself and not just be like a square with like a name and then ultimately like a picture or a video that comes on and flickers and it's like some random dude. So so hopefully I'll see you guys again in this one. Super cool stuff. So yeah, looking forward to, at some point being able to contribute. But it's been great just to get a feel for how you guys are operating this SIG, and seeing some work that's going on.
Yeah, thank you, Ahmad. Yeah, we now know that you're not chatbot. And yeah, if you're interested in SIG
Or am
Node,
I?
we
No, I'm
have.
kidding.
Yeah, with current technology, you wouldn't know, right? Yeah, I just want to say that SIG Node main meeting is in 20 minutes. This is a working group of a specific stream of work. So it's not like a main SIG Node meeting. But yeah, you're welcome to attend either. Welcome.
Got it. Okay, it's the sidecar working group, a part of the Node SIG.
Yes.
Yeah,
Got it.
so
Makes
this
sense.
is very focused on one feature. So in the other SIG meeting, you're going to see a much more broad spectrum of things, where this is just one of many.
Awesome, awesome. Thanks for the clarification, you guys. Cool. And that one's coming up, you said, later
It's
today?
the next hour. Yeah, starts the next
Oh.
hour.
Okay, I don't know if I see it on my CNCF. Well, I think I just added the calendar from, let me see what calendar it is. Anyway, I should be able to find it. Cool. Thanks for the heads up on that.
Yeah, and if you ever get stuck on next steps on how you can help, always ping people on Slack. There is huge work streams to be done.
No doubt. Got it. Will do. Thanks.
Okay. If there is nothing else, thank you, everybody. Have a good rest of the week. Bye-bye.
Thank you. Bye.
Thank you. Bye-bye.